So, triangle inequalities. We are done with constructions. The three constructions that you are required to be able to do are mid-segments, medians, and altitudes, which you just did on that quiz. Now we're going to get into triangle inequalities. What is an inequality?
An inequality is a quality that is inequality.
What is an inequality?
It's something that's not the same. Like different distance, different lengths, stuff like that.
Inequalities.
One is more, the other is less.
So, what's an example of an inequality? Greater than? Less than? Aren't those inequalities? Right? The opposite of an inequality is an equal sign. So inequalities are your less than and greater than signs. So, to start out, the relationship between sides and angles, please fill in the blanks. The angle opposite the largest side is the largest angle. And vice versa, the side opposite the largest angle is the largest side. So let's think about that for a second. Here I have a triangle. Would you call this triangle right, obtuse, or acute? I would say it's obtuse. Where does the obtuse angle occur? At B. So would B be the largest angle?
Yes.
Where is the largest or the longest side?
AC.
AC. Notice that AC is directly opposite of B. Right?
What about a right equilateral triangle?
Well, you can't have a right equilateral triangle.
You can't.
Does not exist.
That's interesting.
All right, so looking at this triangle here, let's list the sides from largest to smallest. So my largest side up here is what?
AB.
AB, 12. So side AB is my longest side, followed by BC, which is 7 units. And my smallest side would then be AC at 6 units. So where would my largest angle be if my largest side is AB? If your largest angle is opposite the largest side, angle C. So if this is my largest side, AB, and I go directly opposite of it, that puts me up there at angle C. So that means angle C must be my largest angle, followed by, what would be next? Angle A, which is opposite of the 7. And my smallest angle would be angle B. Good. Okay. Simple problem. This is on the midterm. Students get this wrong because they don't read the directions. And they'll assume it says largest to smallest, and maybe it says smallest to largest. I don't remember exactly which order it is on the midterm, but just make sure you read the directions of what it's asking you to put the order in. Okay, so don't mess that up. Questions with that type of problem? All right, so the next type of problem we have to talk about is the triangle inequality theorem, which says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So sum means what operation?
Middle.
Equals.
No, all added up.
Plus.
Addition. That's average. Sum is just adding them up, right? So if I add up the lengths of two sides, they should be greater than the third side. So if I go back quickly to this triangle, if I add two sides together, 6 plus 12 makes 18. Is that larger than 7?
Yes.
7 plus 12 is 19. Is that larger than 6?
Yep.
Yes.
6 plus 7 is 13. Is that larger than 12?
Yeah.
Yeah,
Yes.
what happens if
So-
that was like 20, 12?
Oh, if it doesn't, then it wouldn't be able to be a triangle. So you couldn't physically create a triangle with those dimensions. If it doesn't work. You can't do it. It's not possible.
Ow.
Well, here, can you pause and wait till the last examples, and then we can talk more about that?
All right.
So hold on to that thought. So here we have a triangle where I'm giving you 2 of the dimensions. And I'm a visual person, so I like to physically make a little triangle here. One of the side lengths is 11, the other one is 8. So now I need to describe the possible lengths of the third side. keeping in mind that we just said when I add two of my sides together, they must be larger than the third side. Okay, so I'm going to put an X down here for my unknown values of that third side. So now, if I add two sides together, let's use 8 and 11 first. The sum of two sides, 8 plus 11, must be larger than the third.
So it has to be.
So X.
Less than 19.
X has to be less than 19. I like how Jared read that, so I'm going to rewrite it. X is less than 19. All I'm doing is just flipping this. Okay, so that's one option. Now let's do the other combo. Let's do 11 plus X needs to be greater than 8. How do you solve that inequality for X? Subtract 11 from both sides. So then I get X needs to be greater than negative 3. Well, can I have a negative length of a triangle?
No.
Nope, so that one probably is not going to matter. What's the third option of adding two things together?
Plus.
So 8 plus X is greater than 11, which means X needs to be greater than 3. Okay, so we're going to ignore the negative. So can someone give me a number that your X would be less than 19 but greater than 3? 4. Give me another option. 6. What else?
6.
8. 12. Are we able to list all of the options?
Yes.
No, because you got decimal points in there, right?
Oh, never mind.
So there's really an infinite number of numbers that fall between 3 and 19. So do you guys remember back to your algebra days writing compound inequalities?
Nope.
So my solution is my X, so here we are, my X needs to be a number between, so I'm going to bound it by inequalities, 3 and 19.
Not too bad.
And this is what your answer is going to look like. Now, the easiest way to get to this without doing all of this jazz over here, here's the shortcut. Are you ready for it?
See it.
How do I get 3 from 8 and 11? I subtract the two given lengths. How do I get 19 out of an 8 and 11? Kai, I'm glad that your phone is really helping us get the answers.
Doing calculator.
How do I get 19 out of 8 and 11? You add your two given side lengths. That's the shortcut. So if you're asked to describe the possible lengths of the third side, you're going to write a compound inequality. You're going to put X in the middle. Your inequality signs will always face to the left. The lower bound comes from subtracting. The upper bound comes from adding. So if my triangle's two side lengths were, let's say, 5 and 6, what would be the inequality? What would be on the left?
5. No. 3. 6. 1.
1. What would be on the right?
5.
11. If I change my numbers to 7 and 10,
1 is 17.
3 and 17.
How would be 3?
10 minus 7 is 3.
Oh.
If this was 20 and this was 6, what's my lower number?
Negative 14.
Or 14 and
26.
26. See how that works? So when you're asked to describe the possible lengths, you need to write it as a compound inequality. Huh? One more? I thought you said do 1 and 1. That would not work. If we have 13 and 5.
7. 8.
8 and
18.
18. Right? Okay? All right. So now the last type of example that you're going to have to be able to do is, well, what if instead of just giving you 2 side lengths, I give you 3 side lengths, and the question then asks, is it possible to construct a triangle with those side lengths?
That one's not.
So here, we need to make sure if I add 2 sides together, will they be larger than the third side?
And that one won't.
So let's do all
That equals
combos.
10.
Is 6 plus 7 larger than 11?
Yes.
No.
Yes. 6 plus 7 is 13.
Yeah.
That's good. 7 plus 11, is that larger than 6?
Yes.
Yes.
What's the last combination that I didn't
6
get?
plus 11 is
6 plus 11, is that larger than 7?
Yes.
Oh, yeah.
Yes. So since
That
it
one is
works
possible.
for all combinations, yes, it is possible to create a triangle with those dimensions.
Yes.
Okay?
What happens if they're equal length?
That's not greater, so it can't be done.
So this can't be done.
So if we look at B,
It's equal.
if I add 3 plus 6, is that greater than 9? No, that's equal. So that gives me an X, which means that it is not
No.
possible to construct a triangle. Okay?
That actually was response I thought.
That is it.